Hi, and welcome to this video on compound interest. We have a problem here that concerns compound interest. Let's see how we work with it. The maturity value of a savings account that belonged to Peach Company was $28,603.5. The interest charged for the first 5 years was 3% compounded semi-annually and 6% compounded quarterly for the next 3 years. First, we need to calculate the amount that was deposited in the savings account at the beginning of the period, and we need to round the answer to the nearest cent. And second, we need to calculate the total amount of interest earned from this investment, and we need to round the answer to the nearest cent. To work with a problem like this one, it's useful to draw a timeline. Here we have a timeline that goes from now until 8 years later, 5 plus 3 years. And we have that the interest charged for the first 5 years, so up to somewhere around here, was 3% compounded semi-annually. And then after the 5th year, the interest charged was 6% compounded quarterly. To calculate the amount that was deposited in the savings account at the beginning of the period of 8 years, we need to go backwards in time. After 8 years, the maturity value of the savings account was $28,603.5. So we need to go backwards in time to find how much was deposited at the beginning of the period of those 8 years. But because we have different interest rates, we need to work with this problem, and we need to take a few steps before we get to find out how much was deposited in the savings account at the beginning. So first, we need to see how much this $28,000, 603.5 were in the 5th year. How much was in the account after 5 years. And then from that value, we will go backwards and compute the amount that was deposited at the beginning of the 8 years. So let's start with future value number 1, $28,603.5. That's a future value, maturity value of a savings account after 8 years. And let's start going backwards. Between the 5th year and the 8th year, there are 3 years. We have a 3-year period during which interest is charged, and it's charged at 6% compounded quarterly. So we have that the nominal interest rate is 0.06, the decimal equivalent to 6%. So the periodic interest rate turns out to be that nominal interest rate divided by the compounding frequency. And because interest was compounded quarterly for 3 years, the compounding frequency in those 3 years was 4. So we take 0.06 divided by 4, and we get 0.015. That's the periodic interest rate during the 3-year period, the last 3 years. As for the total number of compounding periods during that 3-year period, we compute that value n by multiplying the compounding frequency. So we have 4 by the time in years. Here we have 3 There are 12 compounding periods in those 3 years. Okay. To find the amount in the savings account after 5 years, we need to find present value. This was the present, based on that future value of 28,603.5. To find the present value, given the future value, we use a formula. We use future value divided by 1 plus I to the n. And in this case, we have 28,603.5 divided by 1 plus 0.015, all that to the 12. So value we just found, whatever that is the amount of money that is in the savings account after 5 years of the investment. So here we have present value 1. We still need to go backwards 5 more years. So now to go backwards 5 years, we need to now work with future value 2 equals the present value we just found, 1. That is the amount of money in the savings account after 5 years. We need to go backwards and see how much that money is or was at the beginning. We have 28,603.5 divided by 1 plus 0.015 to the 12. The second time period during which interest is calculated is 5 years long. The second nominal interest rate is 3%. That corresponds to 0.03 in decimal numbers. And now the periodic interest rate comes from dividing J by 2, because the 3% get compounded semi-annually. So now we have 0.03 divided by 2, and that's 0.015 again. Now the number of compounding periods during the 5-year term, the first 5-year term, is given by 2, because we have interest compounded semi-annually times 5, so we get 10 compounding periods. Okay. Let me erase that timeline that we have right here. Make some room for what comes next. There we have that. Okay. Now, here we are. Okay. Now, the amount that was deposited in the savings account at the beginning comes from finding present value 2 equals future value 2 divided by 1 plus I to the n. The future value 2 is 28,603.5 divided by 1 plus 0.015 to the 12. And we want to divide this amount by 1 plus 0.015 to the 10. There we find that. And this amount can be found by using a calculator. If we use a calculator, we get that this amount is approximately equal to 20,614.19 when we round the answer off to 2 decimal places. So that's the answer to part A of this problem. We have gone backwards in time to find the value of this 3 years before and then 5 years before, taking interest rates into account. And we have relied on the same formula. Future value equals principal value times 1 plus I to the n, or if we rearrange the formula, we find principal value equals future value divided by 1 plus I to the n, where I is a periodic interest rate and n is a total number of compounding periods during the term. Now for part B, we need to calculate the total amount of interest earned from this investment. Interest comes from subtracting the future value of the investment and the present value of the investment. The future value is the $28,603.5. When we subtract what the amount of money that was in the account, that was deposited in the account at the beginning of the period, we get to subtract about 20,614.19. And we get 7,983.31 as the answer. So that's the interest earned from the investment of $20,614.19. And the interest charged for the first 5 years was 3% compounded semi-annually and then 6% compounded quarterly for the next 3 years. All right, that's it for this video. If you have questions, write a comment or contact me and I will try to help you. Thanks for watching. Bye-bye.